Continuing our class on AI agents. Okay, so last time we have understand on how this agent will be built from a repository, right? You can find that repository in our classroom as well. And also we call an LLM from a bedrock. We see that how to connect with the bedrock and invoke the model which is a Nova model, right? Nova model we invoke connected to our LangChain agent. Okay, LangChain agent, and also we've seen that some memory agent, okay, which is going to store your chat. Like let's say I have given one question and it is storing, and next time you ask, it is giving back to you. It is storing in a Python list. So most probably you can store in this Python list only. Otherwise, you can use any in-memory things like Redis or any other vector DBs. You can store them. So this is what in the last class we have seen. Now I would like to say that how really LangChain agents, because we have a multiple orchestrators like LangChain, LangGraph, PUI, AutoGen, right? So like this, we have a multiple orchestrators. So on this orchestrators, how we really developing an agent in the real-time use case. In our first class, we understand why we need an agent, how we plan the agent, right? What gap it is filling actually. Now let's run from the LangChain. LangChain is better for tool calling, okay, in a linear, okay. So let's say tool calling in the sense I would be having a user is sending some input, okay, some input. This input will decide, and there's a prompt template. With that, it will call and decide and tell to the LLM. LLM will give you the answer. So this is how the LangChain will be working. LangChain is like a just a toolkit, just a toolkit. It means when I build LangChain, what happens? It is not having it is not having agent state. It's not having agent state. So what is this agent? We need a stateful agents, right? We need a stateful agents. Yesterday, I think your class or some other class, I said like the difference between stateless and stateful. So stateful is something where your input is being recorded. Okay, stateless, it's not being recorded over there, but your input getting recorded, that is stateful. We are maintaining an agent state, an agent state with the LangGraph, but not with the LangChain. LangChain is not having kind of a state management. Okay, state management, what is it? In first case, I have a user. First case, I have a user. I ask, what is your name or how are you? How are you? I ask like this, how are you? So when I ask like this, it will reply me, reply me, I'm fine. And then it wait for you another question. Okay, like we ask one more question like, how about you? How about you? Same question only, right? So what should it answer? As I said, I am fine. I am fine. I'm doing good, something. Okay. Otherwise, you can also have the questions like, where are you staying? Or where are you from? So it will say maybe from HYD. Then again, if I ask, so does HYD means Hyderabad? Okay, like this. It is not having this memory with it. It will be wiped out. It will be wiped out. And next time it will again ask, okay, so can you help me with that? Can you help me with that? What you're asking HYD means. So similar way when I say, hey, there is my order. My Can you check about my order? And you will giving one order ID. And it will tell you that, okay, I have checked about the order. Order is in some status. And next time you ask, okay, will I get the refund from this order? The next question is not having this order ID. That means it is not maintaining that. So that's the problem. Every time it will go in a fresh mode. Every question, it will go in a fresh mode. Can't we add a memory here? Can't we add a memory? Yes, we can add, but there are some troubles with it. There are some troubles with it with LangChain memory. So there are three types of LangChain memory. Okay. So, but the problem with those conversation buffer memory, conversation buffer window memory, and summary buffer memory, and this one. So if you maintain memory, what happens in the first go, in the first go, in the first question, you ask something. This one is storing in the memory. Second time you ask something. This is also storing in the memory. Third time you are asking something. This is also storing in the memory. So fifth time when you ask, it is loading entire memory. Loading entire memory, which is heavy for it and complex and expensive also for the tokens. For the tokens, expensive also. So this is what the memory management is a bit difficult at your LangChain. So that's why in 2024 there is a saying from this Lang ecosystem, if you are building any small chatbot, go with the LangChain in your local or a POC project or something. But beyond the chatbot, anything you wanted to do a more complex and working at the enterprise level, then you have to go with what? LangGraph. LangGraph. It's a graph and node mechanism. LangGraph. So LangGraph will be maintaining this agent state, and it nodes, use nodes and graphs, use nodes and graphs and tools to call, and according to your questions, it will be doing a routing. It will be doing a routing, and based on your requirement, it will respond back to you because it is having nodes. In one node, we will define that. So this is what the LangGraph is famous for, and people are building the agents on the LangGraph for this because it is solving enterprise problems a similar way with the crew AI as well. Okay. So in some cases, LangGraph will be winning. In some cases, crew AI will be winning. In LangGraph, you need to write more code, but it is more enterprise based. Crew AI, less code, and you are building like a agent teams. So 2, 3 agents you can build and you can command them giving a task and roles in the crew AI, and then it will work for you. The agents can talk each other, but here the agents will go in a linear. Linear in the sense, see, in the LangChain it is a if else condition. If else condition like, okay, I have something. I said something. If, if, match, otherwise else, otherwise go. So this condition we will write. Okay. So here we will be keeping same kind of thing. It will go in a sequential way. A to B, B to C, and then result. So you are calling a tools here. You are calling a tools here. With these tools, you call a functions. Okay, functions. That means whenever you say in real time, this is going to call as with the APIs only. In real time, this going to be called as from the APIs. But here, understand like we are going to do a wrappers with the tool. When you ask something, it will come in a sequential way and give you the result. So that is LangGraph. How do I need to build a LangChain agent or a LangGraph agent from a scratch or a building blocks? Go to just LangChain agent code. Okay, first you need to import something like this, but go to the documentation first. And this is Langsmith, I guess. Blog, LangChain Academy. It's a Langsmith. Quick start, LangChain. Always look at this, okay? This document. So you can do a quick start things, or you can do install, pip install this one. You can run through the UV also, pip also, LangChain, OpenAI, and then you have to connect your OpenAI API key as well. Here, export OpenAI key or Google Cloud, Open Router, Fireworks, STN, or Olama, Azure, AWS, Bedrock. You can see this is what in the last class we have done. Others like you have Grok API also, you can use that. So here you have all these examples. Okay, all these examples. So this is the same thing that we're gonna use, the same SDK we're gonna use because it's already proven things, this code. We're gonna use and we tweak something in the real time. Okay, we are not writing everything without using all this. From the scratch, nobody will write. Things are already developed, we use these things. Okay, then we tweak other things, other code for other components. System prompt and creating a tools. This is how we wrap it up and this is how we write it. Okay, the same code blocks will look into this and will take and we will write down. Okay, you can try this one also. The same thing I have built with the collab. Let me go to the collab. Let me go to the collab. Let's this open. Yep. So first you can install the LangChain and LangGraph packages in the collab. Okay. Go to Grok API. Go to this API Grok Cloud, log in and create your API key. Create your API key. This is public API key available and you can use it. like Google Gemini key. So what happening with the Google Gemini key? Nowadays, they are not giving, uh, they are giving API key, but it's not working properly. Okay, previously it was so cool, unlimited, but now they are limited. The quota is exceeding. If you are using one or twice and two, three projects, the quota is getting exceeding. Okay, so with that, you'll be not able to practice your things. Fine. So once you get this, install pip install q LangChain, LangChain Grok, and LangGraph. If you are using Grok API, or if you are using OpenAI, use OpenAI. If you are using OpenRouter, do OpenRouter. So these all things are already available. Run it. So instead of the Google AI Studio API key, I am using my Grok API key. Okay. Let this run. Then I would like to run this one. It is asking my API key. Just come here, edit, submit. Uh, God, it's no copy option. Gen AI 1, submit. Copy it, paste it here. Come here, paste, enter. When you enter, it will take. Okay, done. You can see it's done. Now we are calling this LLM call from a LangChain Grok, import chart Grok. So this is the call. This is a call. This is a call. A call. Okay. Model call. You can use above also. A model call. Model call. Responses. Model call. We can use the model calls. Okay. And then run this. I was asking a question here. Explain KTS stateful set in 3 lines. Just run it because it is going to use Llama 3.1 8DB instant. It's a public model which is accessible from the Grok API. Temperature as per you, whatever you would like to set, and max tokens you can set. Now if I run this, it should answer me with the response. This is your first go. You will be developing an agent on the notebook. On the notebook. Before you're going to commit anything, before you're going to commit anything, you should first take your notebook, uh, create a minimal code, and then see it how it is working first of all. Then add other components because you will be having different APIs, different tools. Maybe a GitHub, maybe a Slack, maybe Kubernetes API, maybe your database connections. Okay, you have an API between your database and your service. Maybe you are having internal service where your internal service exposed as an API. You would like to connect to it. Whether your API already printing those things. Okay, if that kind of information is already there without using an MCP, you would like to connect with an APIs, then you can add that code in the notebook, test it first. If it is running okay, then go for the building the repository. So this is the first thing. The first POC you have to do like this. Now there is a prompt, LangChain prompt template. What we are doing here, I'm just telling a prompt. I'm just telling a prompt that how it has to behave in the next go. So prompt chat prompt template, and then I can define a tool. Okay, LLM. So whenever I ask any question, any question here, first it will look at the prompt. This prompt is actually giving some kind of context to it or a responsibility to it. Like, you are a senior DevOps engineer and AIOps engineer, explain the topics to the student in a simple real world language. So that whatever the topic you are filling here, so it will be trying to give me or trying to frame the answer like this, like this. So this is one thing, prompt template. Then it will go to LLM. If you're giving something else again, L, and you give growth chart, so it will go into the sequence way. Will be going to the next sequence way. Now result, it will invoke that answer and it will print it. If I run this, so it will use prompt, then LLM, and it will respond back to me. Previously also it is answered a Kubernetes stateful is a workload management resource that ensures stateful applications such as database. Okay. Here also, hello student. Today we are going to talk about the LangChain, powerful tool, built-in AI application, simple terms. It uses natural language processing, knowledge retrieval, dialogue management, which is nothing but prompt management only. Okay. So all this, it is explained to me. Okay. This is Lang. This is LangChain. The problem with the LangChain, if I build a repository, call a Bedrock or an API, OpenAI, it is not maintaining a memory. If I maintain a memory, it will be a difficult because it load total memory or buffer memory and not able to do that much accurate. The memory is not accurate. Things will be not accurate. So if you are keeping this at enterprise level in the customer side, no, it is not good. It's not able to manage. So that is the problem with your LangChain. It is just for tool calling, just tool things. Now, when you come to your LangChain, your LangGraph, how your LangGraph will be really working? So your LangGraph will be work like this. Again, any question you have, it will go in a linear flow. That means A to B, B to C. You can also apply some conditional branchings like dynamic routing. Dynamic routing. That means similar way, if else logic only. But you can also go with loop retry pattern. Loop retry pattern as well. That means agent will try until it success. Like if else only. Until it success. This loop you can write down. You can also do with the LangGraph multi multi like multi step planning. This word is right. Okay, multi step planning only we can call, or multi steps. You can plan. Example, you want to be a planner agent and then executor and then reflect agent, or maybe your validate agent or a improve agent. So like this, you can write a steps. You can write a steps, not the agent. You can write the steps. So multi-planning, one after other, one after other, one after other, you can plan in the LangGraph. You can define those things. Let's see how it would look like. If I come here, LangGraph, so you just import those things, and this is a class where your agent is type dict. Agent is type dict. We're maintaining agent state. We're maintaining agent state. So here is a function like understand the question state agent state. See, this is we are calling to store agent state. A question like any question, lowercase or case sensitive anything. If a payment in questions, payment pod. If else user in question, a user pod. If else order pod. Inventory pod, unknown. So this is something I have written in this. Then we have a tool node. Tool node with the state, agent state. The status is check pod status and pod name. The pod name it has to return with what? User pod, order pod, payment pod, like this. So this is a one node. Okay. Then the second one is RCA. Here I'm giving a prompt. This is the one thing and this is another thing. You are an AIOps engineer working in the production. If a question, state, detected pod name, Kubernetes tool results, status, then give this answer. This is another one. Now you can invoke your question and ask for it. So let me run it. Let me run it. Very simple code. You will get it from LangGraph also. LangGraph only. LangGraph code for agent. I just tweaked that. Same codes only. Yeah. Same codes only. You can take. Just a minute. Just a minute. Okay. Sorry, I got a call. Yeah. You can see this a similar way. You can uh, quick start things you can find here. I think it's again a Langsmith doc only. Quick start LangChain LangGraph. Examples. There's a doc. Doc. LangChain LangGraph doc. Chartbot stimulation. Again, these are all the developed notebooks only. These notebooks is just for your things, but see, even itself LangGraph people will be developing this, but you should write your own scripts. Means after this, you are converting into your organization. You have to deploy it. You have to develop it. How? Who? Data science engineer also is going to do it here itself only. .ipvnb notebook. Then he has to convert, put where you are building a repository, that is fine. But where you will deploy it, how do you connect it? So that is a matter. Okay, I'm writing the agent code that is calling fine. I can use code agent that is works. But how do you going to make it workable at your production environment? So that's the thing. There's a document. Let me open this one only. Think in this learn blocks documentation. Nothing for startup. LangGraph. Quick start. Yep. Quick start things you have here. Yeah. tool, defining a tool, a model, and use it and call. So this is now mathematical things it is calling right now. It is here, it's doing multiply, add, divide, like this we're calling. Okay. If you ask any question here, then it will do and it will call in a step-by-step manner. Okay. Now, the same thing here, there is a local server. Yeah, local server also there. It's a LangChain install, UV, quick start, define state, define. Thinking in LangGraph, you can add also thinking. I'll tell you this, classify bug, these things. You can define a flow, agent flows. We'll come to this point. Memory, test, graph API. Integrations. Uh, Not deep agents. Okay, let's come to this. Let me show you how this agent works first. Okay, I have ran, right? Now I have a question like result app invoke. The question is my payment service pod is crashing. Can you troubleshoot it? The moment when I ask the question, here, things are there. Understand the question. And then tool node, what it is, pod status, and then accordingly give this answer by calling your LLM. When I run this, uh, user from LangGraph state allowed and will change the object. My payment service is crashing.
Where you have written that function, check pod status? I can't see it there.
Check pod status here. Understand the question. RCA prompt. Then if the payment is a question, payment pod. If it's the payment question, okay, okay. Then it will do check pod status, state of the pod. Ah, thing is, then it will be reply. Okay.
The check pod status function,
Status
where
is
is it?
not there. Yeah.
Yeah, you haven't written it there yet. Yeah.
So is not defined means the checkboard is being called without. So this function is used in the tool node. Okay. So I was trying to use this, but this is not defined. And let me check another one. Notebook. Can you troubleshoot it? So let me try another question without checking a pod. Pod, which is orders. Okay. Now, one minute. Yeah, sorry. Where are we? Check pod status is not defined. What happened to my pod and orders? Orders question, check pod status, graph age, understand question, generate. Let me short it. I called only prompt template, LangGraph, and okay, okay. So I have to add might be tool function. So in the tool function, I need to say check pod status, then a fake pod only because we don't really have this Kubernetes things, right? So data, let me give this. Let's write payment running failed user pod inventory. Mm, that's enough. Let me run this now. This will get fail. Okay, indentation errors. Now pod if pod. Okay, fine. Unknown also. Open, open. That's the key. Now it ran. Let me call what happened to the pod orders. Okay. What answer? Answer is like pod orders is not available, which means it's running. Let me ask another question about the payment pod. Orders pod and the payment pod. So payment pod is running. Okay. Now let me run it. Here is the answer. What happened? The payment pod is failed, resulting in unknown pod being detected. That means the Kubernetes tool was unable to identify a specific pod that was affected. A root cause is something it is giving a fix. Here, the thing is a fake pod check status we have given regarding the payment pod. It is running, order pod, it is running, inventory pod failed. But a check status, a final answer, what happened to the pod payment? Okay, payment pod. Now it is telling about the what happened. Payment pod in the cluster is not running, resulting is a future and root cause. Incident report pod deleted or terminated is just giving a root cause, but it's not really giving the check. Just a minute, guys. Okay. So now, what we are, so this is actually not giving an exact reason. If you say it's giving a blah blah things, what you can do, a solve or something, the pod got terminated, root cause, something like that. But when I say the check pod is a fake status, the fake status it is not giving. So in this case, maybe we can write like a crash loop back off. Okay, a crash loop back off a database connection failed like this. Okay, uh, this is would be something, and then question not happened, then print results. So in the check pod, right, check pod status, understand question, check pod status, generate RCA, RCA. So here not written, right? It's not written. Okay, on Bono, fine. Let me run it and let me run this. Yeah, now it is giving. What happened? The payment pod is cluster is experiencing a crash loop backup issue, which means continuously crashing, restarting. It's likely to be a database connection failure. What the log I have given here? So this is a log I have given here. So user pod, let's say order pod, say that no issue found. No issue found. Run it and ask about the order pod. Order pod. When you ask about the order pod is running no issues according to the Kubernetes result. So now it is actually checking my status and giving it back to you. This is how you can return some steps into your agent graph. Okay, Lang graph agents. Now, so there is a repository, Quickstart Labs only, into deep diving and understanding how really these things will be working with a e-commerce DB. Example, now we are taken a company is having a DB, a e-commerce company is having a DB. Okay, so I have a DB, I have a DB. So this is my DB. So this DB is having some data in it. Okay, some data in it. I have an agent here. 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 So my agent is connecting to this DB. Is connecting to this DB. In this, I have defined and I have defined a workflow and steps. Okay, a workflow and steps. So when I am a user, when I am a user, when I am a user, when I am a user asking some questions to my agents, how it is reacting about my orders. Okay, about my orders. So there is no back end, front end things. Sorry, back end and front end things, orders. So we're directly dealing with the agent. So this is how first we will dealing with an agent, and then we will see how it is connecting and fetching the information and giving a response back to you. Okay, giving a response back to you. So Neetu, how we do approach POC for an AI MLOps project? Will the data science team provide a reference MLOps architecture diagram? templates, approved, monitoring log. See, a data science team will be only doing their research and development. They will be not giving any plan that how to deploy, where to deploy, how to configure CI/CD pipeline, how to manage your infrastructure. No. So they will be very good at okay bringing your deep learning models, doing a research and development, writing the code, executing over the notebook. Okay, they can also take some responsibility of building the repository. That's it. From there onwards, you have to take the command and then you have to build all those things. So in some of the cases, you always need to be coordinate with your data science team because everything that you develop, you need to satisfy them. See, they are okay, but while you are running that code into an infra, it has to give you the correct inference, right? It has to it has to be expected output. So that is your job. Okay, logging things, monitoring everything you have to do, exploration. Then you have to give a demo, then get the approval and go for it. So this is how at company things will be happening. Data science team is only very good at development and research. They do much things at means data side and AI side means they're bringing up the things, building the solutions, writing the script in the repository in the notebook only. Later onwards, you have to coordinate with them and build everything from the scratch. They say that maybe a Pinecone DB is good, Redis DB is good. That's it. They tell that one only. It's your job that how you will be deploying, configuring, and giving them an endpoint to connect. And they'll say only that maybe vector DB is Milvius is good, and your take is to take the Milvius, create a Helm chart, deploy in the Kubernetes, get an endpoints, connect to it. Sometimes they will give the agent code. Take the agent code, write a script, write a lambda function, okay, deploy it maybe in a Flask or Flask API things. That is your job. And API gateway also routing things. They will be only giving some script, agent script. You take that script, you'll deploy in the AWS app runner. That's it. From there you will take a URL and you'll configure behind the cloud front like this. So that is your job. So these things will really happen at the organizations because people are there for the dedicated works. So your work is mostly getting into how to make scalable, reliable working flow of whatever data science team developed or AI engineer is developed. You will be also part of development as well sometimes. It's not like you only going to be a platform. No, you will be going to be a developer sometimes. Agent, you have to develop it. RAG, you have to develop it. That is your scope also. Right? We've seen in the RAG applications how we write the RAG things. So, especially for Neetu, you can cover up in our next class, maybe in when again we're going to discuss the RAG. For now, just understand this one. We have to develop when the chance will come. We have to be a platform when the role is there. So we are everything. It's not like I will be writing everything from a development. I will be not writing from everything from development. It's according to your environment. So you have to always coordinate with the data science team. Okay. Now coming to this user and agent, let me open this one. There are some labs. Okay. There are some labs I have created. If you see this lab, the first lab is Bedrock. Bedrock. We are calling the Bedrock with Boto 3 and then we are giving a input prompt. Then it will give us an output. Input in LLM, output text. So this is what we have already seen it. Okay. So this will be going to load from my .env. See, .env examples I have given these things. You can replace your code, access key, secret key. Create your .env and give it. This is at the local only. You have to do this. You have to do this. Then only you can able to understand how to build on the infrastructure side. How to build on the infrastructure side. Okay, lab 1, it's a basic thing. We can go with the bedrock, which we have already done yesterday. Now coming to the LangChain. Okay, so LangChain with bedrock and tool calling. So in the lab 1, what I have covered is data fetching. If I am writing something, it use if statements. But in LangChain, LLM will decide which tool to be called. Which tool to be called. Okay. There is a tool function. It will act like the re and act. Okay. React to mode, it will act. If I go to this code, a simple code, again, yes, there are building blocks there. I have added these things. So you can do just import and then load this envs for your bedrock and write a tool. LLM is going to call these tools order ID. If it is an order ID, deck doc, okay. If it is an order ID, order, get the order ID. If not there, no order ID found with this order ID. Okay. Return with order ID, item, total, status, tracking, delivery. So this is the output it has to give from the lookup orders tool. A lookup orders. This is the one tool. And then check stock, product name. Okay. Tool, get policy. Tool, initiate return order ID. And then tool, list customer orders. Like this, I've defined some of the orders. Sorry, defined some of the tools. These are the wrappers. In real time, this is going to be, this kind of things will be going to call from your API. Okay, from your APIs and queries. It will be going to call from like that. And then we create the LLM with tool bounding. That means mapping. Okay. So whenever your model LLM means it is going to take this information from the .env get os.get env, right? Nova Light model, Bedrock model ID, region, and this is the region. You bound all the tools. You bound all the tools. Now you are maintaining a system message that, so this can be always versioned. Versioned means this particular thing you can maintain in a separate repository. You can call it here. You can version the prompts in another repository also. So you are a friendly customer support agent, shop easy, and you have all the access to the tools, lookup, check stock, handle returns, policies. So whatever the map, okay, whatever the question is asked by the user, map it, check the tool, and return with an answer. So this is how it works. Interactive loop manner, which is re and act, reactive. If I run this, if I run this, how it would be going to behave? Git bash. Let me open git bash. First of all, you need to run, you need to go to, there is a requirement.txt, run requirement.txt, and then you can run this. Okay. Go to this readme tool. So readme file. Go to this one, come down, come down, go to this one, activate your VNV. My VNV is already activated, and run it. Pip install requirement.txt. Then in lab 2, Open preview. Just run this. Where are we? ls lab 2 cd labs ls cd lab -2. Okay, LangChain. Now I'll run Python py. So it is going to interact. Okay, load import dot no model env. Let me go to install. I thought VNV activated means it's done. Let's run this one. I've done. Uh, Let me run it. Asking LangChain with the Bedrock tools, is the webcam in the stock? Where is this? In the left side, if you come to the shared, there is a fake db.py. There is a fake db.py. This is a packages again. Okay, you can have two packages. So in this, I have given some fake e-commerce data. Okay, you see customers, customer 1, customer 2, customer 3, Amit Kumar, Priya Patel, Rahul Sharma, email is this one, tire gold, silver, bronze. Orders, wireless headphones, phone case he kept. Total 2499. Shipped, and this is the tracking ID. This is the estimated delivery. Order 2, laptop stand. Order 3, USB hub, mousepad, webcam. Okay. And order 4 is mechanical keyboard. And there are some products. Okay. Products, wireless, price is this much. How many stock is 45. Category is audio. Like this, the data is there from your inventory. Return policy is this one. Return policy. Okay. Now you have a helper functions. So this is where the API calls will work. That's why I've written API calls will be doing like this. Your API will be there. You'll be having one session ID or a beer token, and then it will activate it from the backend. It will pull the data, right? This is how in your real time. If I go into ask any question, a question is like, uh, is my webcam in the stock? Is my webcam in the stock? Bot thinking, I have the stock information from this webcam. Yes, the webcam is currently in the stock with 60 units available and it is priced this much. Okay. Next question. Where is my order? This one. I have found your order details. This is the thinking will not show to you. It will not display to you. If you see, bot will think behind. Then it will respond this one. The order ID has been shipped. 101 order ID has been shipped. These items include wireless headphone and phone case with a total cost of 2499, and the tracking is this one and estimated delivery is done. You can track order by using the tracking number valid. Let me ask written policy. Okay. So I want to return. I want to return. Then what thought? I need to know the order ID for which the return is being initiated. I'll ask the user to provide order ID. This is thinking. The bot is giving you a reply that it need an order ID. Hi, to proceed with your return, could you please give me order ID? See in above chart, I already given my order ID. In above chart, I already given my order ID, but still it is asking, I want to return. It is asking me again an order ID. That means LangChain is not having that memory. If you being also trying to put a memory, it's a problematic thing. Expensive, complex. A normal chatbot, fine, it will work like in the local POC. In notebook, but at the customer level side, no, it will not work properly. So that is what the saying from 2024. Then we can go to the LangGraph. Similar way, the LangGraph are also behaving, but it will behave in a dynamic way. So let me cancel this. Now let me come to the LangChain, sorry, LangGraph. I always confuse. Now in the LangGraph, from the lab 2 to lab 3, what we are trying to solve? Memory is none. Routing is none. Escalation is none. It's a linear, but it is a graph and nodes. See, lab 3 is having full conversation history. We can also do, but it's a complex. Intent and route to handle. It will take intention. Accordingly, it will call the nodes and tools. Detects the frustration and then it will escalate. It's a stateless, it's stateful. That means tracks the intent, customer, and message. That means in the first question, you ask some question. It will also record question plus LLM response. Both it will carry forward for the next thing. In previous case, when I ask the next question, it doesn't have my previous context. But here, it will be having the previous context, the previous response of my LLM. So that is how it will be carry forward between your graphs and nodes and edges. Between your graph and nodes and edges. This is how the LangGraph agent will be helpful. Okay, if I wanted to run, let me see the code. Okay, let me see the code. So customer, we are classifying the intent. What is the intention of the customer? Order node, return node, product node, escalate. We have these four things. Then it will use a tool and LLM and generate the response. Again, we know this. Import the things, check out product stack, get customer orders, get return policy, request return. Load them from the .env. Okay. Now this is a class where your agent state is. Agent state is. This is an agent state. Okay. Now the tools are like, just a minute. Okay. Now the tools are like, so the same tools that we are using at the lab too. It's were quite easy and understanding. Okay. So look up orders and check stock, get policy, initiate returns, list of the customer orders, and then we'll do LLM calling. Okay. LLM calling and the graph nodes and the graph nodes. So now this is first node. Graph node is classify the intent from the agent state. Like in the LangChain, we have agent state, right? So that means I have a question. My question passed to a tool. Tool is given an information to LLM. LLM given a response. That response in this agent state. Okay. Now to classify it means the classification of your intention. Intention. In this, we are saying that customer wants replace or whatever the message that you are getting, the content, classify the customer message exactly in one category. We have defined the category also, right? Order status, return, product, escalate, general. So this is the category in this classification of the intention. If nothing, then return with nothing. Okay. Then LLM will understand on these categories. Then handle with the tools. According to your intention that your intent classification done. Let's say order status, return or a product, whatever it come. Then you are a friendly customer support agent for Shopee. Easy. Customer intention is intent. What intent? Written with what intent? What intent? What intent? So that message your LLM will take and give you a response to you. Okay. This is how the response to you. Then handle escalation. What the agent state? It will be sentiment like angry, frustrated customer. Then give this message in this node. So these are the three flows with the graph I have defined. The routing will be happen on the intent. The routing will be happen on the intent. So this is how the graph will work. This is how the graph will work. Classify the intent, take the intent, escalate to handle the escalation, then end, else handle with the tools. So if I run this, if I run this, if I run this, lab 3, okay, if I run this, it is going to ask me the questions. Okay, these are the questions now. I'll be going to ask, hey, what are the products are there in C001 customer? One customer. So now it is telling that thinking I have details with both orders of CZ01 and summarize the products of the customer. Customer is having the products like order 0001 wireless and phone case and order 2 laptop stand. So let me know if you need further assistance. Okay. Now what I want is customer 1 or C001 is ordered webcam. Can you check? Can you check? When I say this question, thinking I have checked the details of both orders and neither orders webcam. Customer doesn't have any orders including webcam. If you need further assistance, feel free to ask. Actually, I want webcam, not the other orders. So I would like to return it. Return it. Then what it will give me the answer. Sorry for my spelling mistakes. So the customer wants to return webcam, but they do not have orders that include webcam. I need to inform a customer about this, provided them with an option to purchase webcam if they wish. So this is the thinking of the bot. Then customer see, it seems do you not have orders with include webcam. If you would like to purchase webcam, please visit our website or contact our customer service assistance. If you have any other wish to return, your any other orders wish to return, please let me know with order ID and then I can help you initiation a return process. What is my order ID? My order ID is this one. Copy this. Hey, because we have two things. Here you go with order ID of return it or return my money. So it was telling that here's a question, but the return process cannot be initiated because the order status is shipped. So it must be delivered or with a return. I need to inform the customer about this. This is what the thinking is. So I'm sorry to inform you that the return process from an order cannot be initiated because the order status is recently shipped. Proceed with the return. Order must be delivered. Please wait until it is delivered and then we can initiate a return process. If you have any other orders are delivered, if you wish to return, please let me know. So what is a return policy? If I ask like this, now it will give me. See, it is exactly dealing like the real-time agent. Okay, a real-time. This is how the sample agent we will be deployed on the production level. We connect through an APIs or MCPs with your databases, with e-commerce databases, where you have inventory, register things means your user profiles, register things, everything. This is how it will answer back to you. If you go and chat with Amazon agent, it do the same thing for you. It do the same thing for you. This is a simple code I'm showing, but at the organization level, it is a big repository. Okay, with multiple components. It is a big repository. This is LangGraph agent. Similar way, we can also develop Crew AI agents, an orchestrator, the less code and easy. Less code and also easy, that agent to agent talking can be happen. Here what happening, one agent, we have defined nodes and graphs, a flow, this to this, like this. If this is a function, go here. This is not, then go here. This is not, then go here. Like this we are saying in a loop and retrain things. But I want 3-4 agents. I want 3-4 agent. So in that case, I can go with Crew AI also. I can do with LangGraph also. But it's good like this. Crew AI, you have multiple sub agents, an agent to be validate, an agent to be executor, an agent like this. LangGraph side, you can use supervisor agent, and then you can give other processes. Accordingly, it will give you the response. This is your planning. This is how we need to take a problem statement, develop, deploy, and show the results. If this same LangGraph, if I would be deploying at the production side, how it look like? This is exactly look like this, a front back end and front end. So what happens, we never deploy any agent any agent directly in the front end, because because web app application, we never deploy things in the, so this is your front end example. Front end, what people will be doing as a POC project or something, you just invoke your agent in the front end directly, and your agent code and those things, okay, even though it must, but the credentials of your LLM and your code is directly being injected at your front end side, and someone is did an attack at front end side. Front end side is very easy to grasp or take the data. If that is being there, then some cross-sighting we can be happen, or maybe some injections they can do. So if that is a thing, then your things will be gone. This is risky. So we never do a development like this. Then what we'll be doing, we will be first developing the backend. Developing the backend. Once we develop the backend, your backend will be connected to your agent with an API, which is fast API. Okay, which is fast API. With this, you will connect, and your agent's things will be here. Okay, okay, like this. And your request from front end, it will come like this, and it will go like this. Your backends. First, you'll maintain a backend, and you'll be also connecting an API here as well, if is that the case. And you will define one auth method here. Okay, auth method. The moment any user is making a session, the moment when any user is making a session, a session, a session, a session ID will be carry out. Okay, with that only your things will be responded to you. For each user will be responded to you like this. Okay, if I go to here, the fourth lab, which is a backend, a code is there, the same code, same thing, is a fast API code. Okay, it's a fast API code, a simple code only, it's not big code, and a front end code, which is Streamlight. You can develop from ChatGPT also. This is not a big deal. This Streamlight code, but this backend codes, you just careful, iterate multiple times, then only it will work. And then infra. Okay, so infra thing you can go with AWS also, and packages. So here, how you define your agents. State agent means files, agent.py, state.py, tools.py. In my backend, I'll be only having one file from a Docker file. I'll create the Docker image, then I'll push it into the ECR. From there, I can deploy. Okay. If I go to agent.py, I go to agent.py. So this is my agent code. The same code only, same file, no difference. Same file of for lab 3. Okay, state py. The small code block from the first line, right? I took it and place it here. Tools.py, all tool things you will keep it here. So this is how you maintain your files in a separate repository or a separate folder. You never always write all these files in every agent. You will define this, and you have multiple agents, then agents will use these files if it is needed. Like this, you can write your code. I can develop from the Docker Compose in the local first, then we can go try to deploy in the AWS if it is possible. Right now, I've written a Docker Compose file for the backend build and then the front end build. Okay, let's run this. Let's run this in lab 4, right? It is cd lab and lab 4, right? Now just go and run a command of build this one, build docker compose build. It will build your containers, build your containers. You can also check from the Swagger as well, or Postman also. People will be doing checking from the Swagger. Okay, sometimes you'll be defining an auth method, right? The auth method or bearer token or session ID or OAuth things, JWT tokens. You can define them. Yep, it is running right now. It is running on the localhost 8501. 01. So I can do this chart of localhost HTTP. Let me open the Postman. Open the Postman. So this is my Postman. Okay. Here I created, and you can create a new collection also. Let me delete this. Delete, delete, delete. You delete it. Okay. So you can create a new collection. Add request. Request is get or post. A post request. Okay. Localhost 8000 chart. And then come to your body raw, and you can ask this, where is my order ID? Where is my order ID? If you ask this and send it, it's replied to you. Okay, your order ID is this one, has been shipped with session ID. It's maintaining one session ID now. You can use this session ID for further conversation on the same thing. Okay, for further conversation on the same thing. If you come down, you can ask now, can I return it? You need to mention session ID. If you are not maintaining session ID, what happens? It will be thinking in a generic way. Okay, it never know about your order. Okay, what you do? Just copy this. Okay, and go to Postman. You do one time is done, right? Now let me copy and remove it. Okay, and remove the this one also. Send it. Thinking that the customer is asking for the return, provide me accurate information, need to know the order ID and check the return policy. I will start with the asking order ID. See, it is asking order ID. Okay. Now, oh, session ID we forgot, right? Shit. Let me ask this. Copy this session ID. Okay. Then now copy this and now come to your this one and paste. Now this session ID, right? Can I return? You can see the difference. See, it is giving the difference that according to the Shopee's return policy, you can return this within 7 days of delivery. See, it is having order ID information because a given intent is written. Intent is written. Session ID is this one. That's why whenever you go from the front end and you're making a session with any agent, this is how it stored the memory. This is how it's give you the results. Okay. So it's give you the results. This is how it exactly works. Are you all getting it or any confusions on this agents? Like, are you all getting this lab, right? Thumbs up, thumbs down, at least. Super. If these labs, you just run and add an output in your repositories and add it to your profile in the GitHub pages. Add that GitHub page into your resume. Then study something around these agents, how it is. Because when I'm going to deploy on the infra, like we are going to develop, right? Memory maintenance, Bedrock, Agentic core, and now next is an MCP. You should have a good knowledge on this now. Okay, now we are only learning how to building an agents, the pattern of the agents. Now let me go with agents, sub agents, 3, 4 agents connecting with the crew AI. Okay, and then building a RAG application for it and one database for it, and then we'll see on the Kubernetes. I'll be create one database. I'll create one agent over there. I'll deploy an agent under some service. Okay. If I go with like that, then how our practical things will work. That is, I want to show you. If you have this hands-on, in the last, it will be very, 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 very easy. In the last, it will be very, very easy. Okay. Now, you can also deploy in AWS App Runner. You can deploy in AWS App Runner, where this agent you can deploy AWS App Runner. Easy, easy. You deploy this fast API in Lambda. Easy. Why to go for this agent to be into the Kubernetes? If it is okay to run in the AWS App Runner, okay, AWS App Runner. Just create a Docker image. Just create a Docker image. Fully manage that allow developers to quickly deploy containerized web application and APIs without managing the servers or a infrastructure. Zero infra. Okay. You just create a Docker image, just deploy over there. It will give you an endpoint. Take that endpoint, put it into your CDN, content delivery network, cloud front in the AWS. That's it. Write your restrictions over there. Then you can do that. Okay. If I would try to create that, you should create a Docker image first. Then you have to push it to the ECR and then deploy it. Can I give you this homework? I'll give you the things also. Can I give you this homework? Homework is you should try with AWS cloud. Okay. What do you do? Create an ECR repository. Okay. First step. First step is step 1. Create ECR repository. Step 2. Authenticate from your local laptop. Third step. Step 3. Build Docker images from the repo in lab folders, which is lab 4 folder, because the Docker files are there. Step 5. 4. Push Docker images into ECR repo. Okay. Step 6. Create an app runner in AWS. Step 6. Step 7. Deploy this Docker image into app runner. Step 9. Sorry, step 8. So your app runner will give an URL. Take this URL. Okay. And step 9. Keep it in Postman tool, and then do a chat with /chat. Okay. Do like this. Will you able to do this homework? Homework, please. Yes, no. Can you able to find the commands for this, right? Will you able to find the commands? Ask ChatGPT, it will give you the commands. Not a big deal. CLI commands, AWS CLI commands. You can do through the AWS CLI commands if you want. I didn't mention any commands in the README. What I will be doing? See, I will define like this only. Any lab I am building, I will write clear what I'm thinking in my mind. I'll write clearly. Then each step, I will, whatever I know, I'll go to the document. And from the document, I'll read. Then I'll take them. Building a commands again headache to me. I'll go to ChatGPT. I'll give my context that I want to create an ECR repo. It will give me a command. I'll copy that and paste in. Then what I'll do next? I would like to auth it. Then I'll build a one more command for it. Then I'll paste it in somewhere in the notepad. Then I will build one more. Then I will build one more. Our labs also I'm doing same thing. I want to create one tool. I want to create one function. What I'll do? LangGraph, what it will support. First I will read. See that. What is it? Learn about it. Then how can I map it here? Then I will map it. Then I'll see, is it really helpful in the real time or not? Yes, helpful. Then I'll build a block for it. That block, if I'm writing, it will take time to me. I have a clarity. I'll go to ChatGPT. I'll put it there. I'll ask to write a block for it. It will write a block for me. I'll take that block. I'll put it here. I will run it. If it is giving me an error, then I'll try to sort myself. If I'm not able to sort, then I'll go again take an LLM help. Then it will sort one more time. I will take that. Then I will map like that. Every lab I'll build like that only. Then only we'll understand how to develop a lab, how to work in your organization also. This is how you do. So it is not like I given entire these things and it is given a sequence. No, check each step. Check each step. This all steps I will combine and put it in a notepad. Then I'll beautify. with some this markdown files, because markdown files writing is not easy. I'll keep in the markdown files stars and all those things, and then indentation errors, then I'll write it down with the Gemini. This is how I'll set up every readme file. So you should also do from now onward the same thing. When I give any homework, take the steps, I'll give you the steps, search it, do it, put it in a notepad, and then execute in a sequence manner. Okay. Questions. I think if you do this, we'll go for the next thing is like crew multi-agent, crew AI multi-agent. Okay. And then we'll go to the MCP also. And then we'll see memory things also. And then we'll go for a bedrock, native things. Again, AI Foundry one time I'll touch. And ADK from Google GCP side. Okay. We'll once we have a good clarity on the agents part, then we'll do a real-time lab by building front end, back end, DB, everything. Okay. We'll connect with APIs and MCPs. Then we'll see. Okay. Many things I have to teach, but okay, please do your practice so that you will have a good time for us. Then it is easy for me not to cover the basics. I can go in high level. Cool.